Good evening.
Hello. Hi, Zala. Hello, everyone. Hi, Pritesh. Hello.
Hello.
Hi, Pritesh.
Hi. Good evening. Upendra.
Good evening.
Good evening.
So, am I audible clearly?
Yes,
Yes.
yes.
Great.
Rupendra ji, also make Vishal co-organizer.
Yes. Yeah, I'm doing that. Hi, Vishal. Vishal, I have made you a co-organizer.
Thank you, sir.
Hey, good evening, Vishal.
I agree. Am I audible enough?
Yes, I can hear
Always,
you.
as always.
Yeah, thank you. And good evening, everybody. So we have Pritesh here. So basically, it's my privilege to introduce, our distinguished speaker, Pritesh Mashru here. He's basically a chartered accountant and CISA certified professional, bringing his deep expertise in finance, technology, and governance. He is seasoned leader with extensive experience across industries such as manufacturing, FMCG, engineering, and industrial automation. With a strong skill background, he is in IT audit, SOC, uh, compliance, risk and controls, ERP governance, and a lot more. He has been instrumental in designing and implementing robust control framework across like SAP, Oracle, Navision. He works, uh, his work spans into IT, general controls, access governance, uh, uh, segregation of duty, and technology-enabled assurance program. What makes him perspectively particularly valuable today in his focus on AI-driven analytics based on monitoring and compliance, an area that is rapidly redefining how organization thinks about controls and assurances. So today's session from rules to algorithm redefining controls in AI era is highly relevant is the transition from traditional rule-based control environment to the dynamic intelligence-driven system. Please join me with extending a warm welcome to Mr. Pritesh Mashru. Thank you.
Thank you, Vishal, for this nice introduction and welcome. Are we good to go? Can I start?
Yeah, please go ahead, sir.
Yeah. Oh,
Okay,
thank you.
so hang on, just for a minute. I would like to also announce that the participants attending from outside of Ahmedabad chapter are requested to send an email to Isaca Ahmedabad chapter at gmail.com to obtain your CP certificate. Thank you. Please go ahead.
Oh, thank you. Thank you, Vishal, and also Zalak for bringing this forum together to share my thoughts on the controls, the dynamics, the how it is changing in the AI era. So, and I also thank and I appreciate really the attendance who are, over the long weekend in between have shown zeal to come up and spare their time for this interesting subject. And I'm sure that by the end of the session, I believe that you would feel that it was worth spending time. This an hour will really go a long way to come on board on this upcoming subject, how the dynamics are changing in this field. So without much of the time, spending much of the time on other things, let me just come to the topic and start my thoughts around it. My screen is visible, PPT?
Yes, go ahead.
You can also just share the PPT. The whole screen is shared.
Okay, let me just try it. I'm not very familiar with Zoho, so please pardon me. What I said, we stop sharing, and now I will share a window. Right. Fine now? Yeah, shall I go ahead?
Yes,
Yes, the stage is all yours.
Oh yeah. I hope my screen is clear and my voice is also clear.
Yes, it is fine. Yes.
Yeah. Good to go?
Yes, please.
Oh, thank you. Well, so in today's session, we'll talk about from rule-based to the algorithm-based controls. With the advent of AI era over the last 3 or 4 years, I think it has been more familiar to Indian at large after the emergence of ChatGPT. And since then, every alternate day, or rather of late, every day, there is something new emerges on the AI front as a new development, and that keeps us, wondering that, where we are leading. So the only theme in this changing environment is, to continuously keep learning. Only we will experience in today's session that what we need to unlearn or relearn as far as our knowledge on controls goes. And then, we'll see that how does it make sense for us to move in this changing dynamics. So first and foremost, that why this discussion is important at this stage. Now, if you look at controls in traditional literal sense of control, the control is control. At the end of the day, it is an activity of monitoring and correcting certain things as a managerial control. Now, it has been in existence for ages. It has been in existence for probably decades, even before IT was there in the picture. And since IT, of course, the controls have been there. But certainly how the controls look like have changed over a period of time. It is going to change with the advent of AI, how they are going to operate, and who is all accountable for the controls. Now, in this area, I have broken my today's discussion in these 4 overall parts, wherein in the first part we'll see how the AI has challenged the traditional controls. The controls that we were traditionally building in our systems, we are used to audit those controls and we used to maintain and update those controls, how they've been challenged with the AI. Typically, our traditional controls had been rule-based, and in an AI era, where the changing behavior of the systems makes those traditional controls come under certain threats. Some new risk arise if we just continue to exercise the traditional controls. Now, it also creates a new opportunity for the auditors to audit the new kinds of system, that is the AI systems. But of course, those new opportunities come with its own set of challenges. And in today's discussion in part 2, we will examine that what are all those challenges and what could be the possible solutions to meet those challenges as an audit professional. And also there are certain framework changes that have been coming up. We'll also briefly touch upon them. Now, certainly AI has brought its own advantage to the audit function also. While the business has been, very apt in adopting the AI technologies to its advantage, the auditors also has an advantage. In the third part of our discussion, we'll see how audit function is added with certain AI tools in terms of, NLPs and machine learning technologies. Certain tools are available for the auditors, and how it can really add to the efficiency and, can probably also help to meet the challenges of the new areas of AI auditing. And lastly, but not the least, how the explainability of the AI, or certain basic risks that are seen by at large on the AI systems are in terms of whether AI is accountable or whether AI is auditable at all. Now, we would have seen that even as simple regular usage of ChatGPT, at times we wonder that, when I asked a question yesterday through the same login to ChatGPT, it gave me some answer, but today it is giving me some different answer. What has overgone within one night that ChatGPT is behaving differently. Now, this raises a very important question about, how do we hold the systems accountable, the AI systems accountable? And also, how do we build the AI systems which can be audited? So making the systems audit ready is an important thing that we'll deliberate. The first part, how the traditional controls have come under threat, or what kind of additional risk that have arose in the traditional controls. The first thing, if I have to talk about the traditional controls, if we understand them in terms of their DNA, again, those characteristics of those controls from the AI lens, then it becomes very apparent that, how those things have come under threat from AI. So first thing, the first characteristic of the traditional control is these controls are deterministics. The same input always gives the same output. There are no surprises. Like if you put a threshold limit in a transaction processing system, say 10 lakh rupees, then any transaction above 10 lakh will behave in a particular defined way only. In an AI scenario, when probably you would have probabilistic systems behavior, the same input may not give a different output. So this particular control characteristics that we are used to as an auditor has undergone a drastic change. Now, second characteristic of the traditional control is that they are all authored by humans. Basically, policies, the coding, or even the thresholds. In an AI system, this itself is changing. That initially we feed the systems with human authored controls and checkpoints, but as the systems grow, they mature. There are so many controls that they build itself for certain characteristics that they develop, which probably are not, we can say, human authored. The third one is that the traditional controls are pretty transparent, that you can read a particular control, you can document, you can test it as a developer or even as an auditor. But then the transparency was very clear that if something has happened, why it has happened, and how it has happened. In AI area, it may or may not be very clear. That control, how it is working, is very clear to you. We'll see an example, how the control becomes better in an AI system, and how those controls may remain semi-transparent to some extent. Then the controls are static by design. The rules do not change unless a human changes them. In AI era or in an AI system, the rules may change by its own. As the systems, the models grow and learn, they may change itself to adapt to the new situation. And again, the third one, the last one, the characteristic of a traditional control is that they are binary outcomes. Either yes or no is the answer. Whereas in AI scenario, there are gray zones in which the answers remain probabilistic, or even multiple options emerge as an answer. Now, these are some characteristics that are unique to the traditional controls, and also they come under threat in the AI era. Now, the same controls, if we see it from a classification perspective as an auditor, we are used to see the controls in this three categories. The first one being that the controls are either preventing, they prevent the issues to arise from the beginning itself. And if they escape from those preventive controls, then there are detective controls, which identify the issues or anomalies in the transactions or in the systems. And then if at all they could not be detected, then at the end we look at the corrective controls, in terms of rollbacks or BCPs and the DRPs and all those things. Now, this fourth category or the fourth dimension of this classification is directive controls. Of course, these are something not new, that those policies and procedures and workflows and SODs we have always been talking about in even traditional control era. And if you think slightly in detail, these directive controls were really, they are all overall controls which were translated into practice. And when they get into practice, they fall in any one of the earlier three categories, that, any policy guideline or, any procedure that is prescribed by as a directive control, when you translate into practice, either they fall in preventive, detective, or corrective controls. Now, this fourth classification becomes very important when we transition the control to the AI era, and that is because those controls are directives, and when we build the AI models, these directive controls become very, very critical to design the new systems and the controls around those systems. We will see in detail as we pass through the fourth part of our discussion today, that how directive controls translate into the building of an answerable or accountable and auditable AI system. Now, let's look at how the traditional controls are challenged. The traditional controls we have always seen in this broad 5 areas or 6 areas. and like access controls, segregation of duties, input validation, audit trails, change management, disaster recovery, and DCP, and all that stuff, which we have been traditionally either practicing as the systems persons, or we have been auditing all these controls, typically classifying them into these areas. Now, how the traditional approach for each one, like access control, there is static role-based access control is granted. Whereas in the AI era, this is changing, because particularly an agent is acting, AI agent is acting, and there is no role particularly defined for any agent as such. So what is the risk implication? There is a privilege creep. In access-based access controls, which were role-based, you could restrict the control to individuals. Say, for example, a sales manager could not see the payroll data. This was something, apparently you could have designed based on the roles. But when in an AI system, the agent or the algorithm will have full access to all the data. So this creates a big risk for us as an auditors. From segregation of duties SOD perspective, the humans were identified to separate roles. And the idea was to prevent the fraud or error. In AI era, because AI handles end-to-end processes, the entire concept of SOD comes to a collapse. And because of that, it becomes a single point of failure. And then, once an AI agent is compromised, there are least of the possibilities to prevent fraud or error from happening. Input validations, we had a lot of validations in place when we designed the systems in terms of field types, range, and formats, and so on. But AI systems typically accept the natural language. They can accept any kind of documents, images, or any stuff. And, there are very limited controls around this. Because of that, the systems become prone to adversarial inputs. Some inputs which are given to the system, which system would accept, and it can create the very basic purpose of it can it can really mar the very basic purpose of the system itself. Even the data poisoning, if it goes through, then the model behavior is becoming unpredictable, or maybe prone to some frauds. Now, some kind of controls have come in place here. To give an example, in terms of input validation for an AI system, like certain OpenAI systems, for example, ChatGPT, Copilot, or maybe Gemini, or so on. If you try to give inputs which are pornographic, or using certain languages which is unparliamentary, or maybe some personal derogatory things, that if you try to give as an input to the systems, there are some basic checks which have been built, which the systems will reject those inputs. From audit trail perspective, there was always a log available, typically in traditional controls, which we can read, and what has transpired behind the system, we can always come back and examine them post facto. Whereas in AI, the decision or the actions are based on so many weights. If you look at the ML machine learning models, the decisions or actions are based on the weights and the probabilistic rules that are defined. So there are a lot of touch points in the system and the data. So what happens is, you cannot reconstruct a particular decision in an AI system. As I said, the same input can give a different output at different points of time, or even by different IDs. For different IDs, it can give different output. In terms of change management, we used to have controlled change management in terms of documentation, the testing, and the entire change management process was involved. The approval process was there. Now in AI era, any model which is a continuous learning model, the changes happen in model by itself. So what happens is that you have very limited log or visibility, or a control over the change in the model. So what happens is that something gets built into the system over a period, it can bring a drift in the model, or the model becomes prone to unexpected behavior. In terms of disaster recovery and business continuity, we had well documented, processes which were periodically tested. There were clearly defined RTO and RPO, points, which probably becomes very, very difficult because AI systems typically degrade over a period of time. So the model recovery and, retraining may or may not be feasible, or it may be very, very difficult. So what happens is it creates a very tandem situation when business continuity is in question, that you cannot identify. I mean, in current practices, there are no tested recovery paths for the model failures. Even RTO and RPO becomes very, very unpredictable. So these are the challenges that traditional controls face when they are as such applied to the AI systems, and because of that, the risk dimension increases. It becomes, these controls becomes inadequate, so that you can get proper audit assurance. And our traditional existing frameworks in terms of SOX and IOSA and other things, they're all really are not able to cope up with this kind of dynamic scenarios where the controls becomes inadequate. So these are some examples in terms of access controls and segregation of duties, that how they've changed over before AI and after AI. Like, not going through each of these lines in the interest of time, let me just quickly talk about a particular thing, that audit log, which earlier logs tied to the name with human identities, that any transaction or any event that is happening in the system, where always log with an individual with timestamp. But in AI, a single algorithm is reading, writing, deciding, executing, answering, acting upon in all the and has got full access to data and all the actions. Now in this scenario, the ID management itself becomes a very big challenge. How do you track which particular part of algorithm has done what? So the result is that the existing frameworks cannot address the identity governance for the agents. Now, really, it's an upcoming area, a new AI identity management, some framework is needed, some maybe standards framework or maybe some legal framework will have to emerge. And we can clearly see that, in the DPDP Act, which has come up in India recently, the consent management is one of the things that is very important dimension in the overall legal framework. And in that, the identity of the data, the person, the data owner, and the systems which are dealing with those data will be the responsibility of the consent manager. So it's of course not directly addressing the AI identity management, but certainly the users of, different AI system users of the personal data is being tracked by the consent manager. So it's a first step, but welcome step from legal point of view. Now, because of these challenges that traditional controls face in the AI systems, the information technology audit framework, which is by our parent body, that is Isaca, they have recently come up with the 5th version. And there is a clear-cut shift which has happened between 4th version and 5th version of IATF. It is very pertinent for us as an auditor to know what kind of those shift is, how it was earlier and now it is. If you look at the first shift, there are first isolated controls were looked at. Now we have to look at the system as an overall ecosystem. The control boundaries were probably defined to the organization or the perimetric controls in the organization. But now really we have to go beyond the organization. The IATF is expecting that we look at the cloud, the SaaS, the APIs and third-party dependencies from the very beginning of the audit. So this is a big shift that is happening. The second part, earlier the focus was on the control, that if the processes were followed as were they were designed, or the processes were adequate enough to not qualify as a failure of the control. But now here from control, it is like, can we stand behind the outcome? So can we really trust the system is the remote question that we have to answer as auditor. Now this is creating big expectation gap between what auditors currently do and what the standards are expecting. Now the next thing is from periodic review to the continuous insight. So you just used to do on a quarterly or annually certain cycle reviews, but now the IATF 5 version is expecting us to be on board every time and in real time almost flagging the risk. Earlier, the focus was on sampling. You do a scientific sampling from the population, statistically methods you apply, and then you could come to the audit conclusions. But here, there are tools available, and even the framework is expecting that we look at the entire population before we give us opinion about the systems. The operational focus versus governance and accountability. Earlier, the focus was that if the controls were operating properly, and if yes, then we used to give a clean report. Now, of course, the governance was important in earlier framework, but now it has gained more and more focus, because ultimately it is the system who does everything, but system cannot be alone held responsible for everything. There has to be a governance, the human governance at the end of the day to control the systems. Lastly, the control function versus a strategic partner. Many of us as auditors would have experienced in our practical life that while we act as a assurance partners or assurance professionals, but many a times management expect us to be a consulting partner for them to build the systems which are robust. Here the same strategic partnership focus, which was in practice by some advanced professionals, has been brought to the formal framework. So these are the transforming shift that has happened in terms of the framework horizon. Now, these were the systems that we saw, systems of controls that we saw earlier. Traditionally, how they're working and what are the challenges and how there are certain solutions around it. Hitherto, we were auditing all systems which are kind of static. Now, when we look at any AI system as an auditor, what kind of challenges does it pose to us to discharge our function, and how those challenges we can meet, what kind of possible solutions we have when we are in a scenario where we are auditing an algorithm versus earlier that where we were talking to people and we were auditing a standalone static system. So these are the 5 core challenges in auditing an AI system. The first and the foremost is the explainability. The question is that can the decisions derived by the AI system be explained? Are they fair, consistent, and based on permitted inputs? So first thing is that whenever we deal with an AI system, or even just when we ask a simple question to an chat GPT or any GPT for that matter, the first question that we ask ourselves is that, can I rely upon it? Can it tell me that how it has arrived on the decision or the response? When we talk about the standalone AI systems which are used by the management for business purposes, there are certain tools in terms of SHAP and line tools, which are typically can measure the impact for each of the model's features, or the relationship between input and output. These are the 2 tools or the concepts which are prevalent in the market, which can help us to understand the explanation of the system's behavior. Even while building the models, there are attributes that have to be, ideal as an ideal process that system developer has to translate to a card, which, explains what are the features of a system and what are the boundaries of an AI system. Those are the things that we can, rely upon to address some of the explanatory challenges. Then there could be, there's algorithmic bias. So has the model been tested for disparate impact across all the projected characteristics? Now I'll give an example here where, Amazon had built an AI model to automate their recruitment process. Now in the process, they, could not detect that there was some bias in the algorithm itself, and which crept in because of the historical data. So what that model was doing is, it was, giving less weight to the female candidates, and that particular behavior of the algorithm was because of the historical data were, showing certain trends to the model. Now this kind of algorithm bias, if it comes into picture, it becomes a real risk. So what we have to probably rely upon, there are fairness matrices that have to be built up when designing any AI system. The odds have to be equalized before, algorithm can be put into live systems, and there are certain parity checks that can be, put in place. The third important challenge while auditing an AI system is the model drift. Now, what we audited 6 months before, is it the same thing? Probably no. So continuous monitoring is important. Instead of, periodically auditing any model, it is important to keep under continuous monitoring. So audit becomes more and more concurrent, and, auditor's role becomes more and more integral to the operations of the AI systems. Now, data lineage is another feature which creates a challenge for the auditor, that, the data which every feature is using has got what kind of authenticity it has got. Is there any track record of the data that is flowing into the system to, train or, rebuild those logics and decision algorithms? So yes, there are data catalogs, the lineage tracking, the training data audit trails are important, which can come to the help of the auditors. The next challenge, that is the accountability challenge, that, someone cannot say that, system has done it, or, it is the AI partner who has done it, who is responsible. There has to be AI governance charter, the RESI metrics, and third-party model audits, which can, help to come to the help of auditing professionals. Now, another important thing is that what can make auditors' life easy, and even the life of the programmers and designers of the AI system easy, that if the auditors are involved in the entire life cycle of AI model building. So these are typical stages of any system development, that you define the objectives, you acquire the data, model development, or, from systems perspective, you develop a system, you validate and approve, then go live, you continuously monitor, and then finally you have to retire the system when the utility is over. Now, if auditor is involved, and, certain questions are addressed at each of the stage of the auditing, it is very much helpful to the auditor. Just pardon me for a while. There is something. Give me half a minute, please. Sorry for that inconvenience. I had to attend something. Sorry about that.
That's fine, Pritesh.
Right. So while defining the model objectives and, acquiring data, certain questions have to be asked, that, are these objectives of the model are aligned to the business objectives? Whether they are documented well, those objectives, the data lineage is built, the consent is obtained, the legal validation has been obtained for the data that is being used for the building and training of the models, whether there is any bias which is pre-screened. So these are some of the questions that have to be answered. Auditors can certainly step in at that stage and help the programmers or the developers to come up to that level. During model development, define the model cards, which identifies the attributes of the system, the boundaries of the system, what are the success factors of the system, and then you also develop the validation testing, the sets that will qualify the system to go to live, and then certain benchmark that have to be documented that, to be a best of the AI. Then in terms of validation approval, auditors can play a role of as an independent reviewer, also can test the fairness of the outcomes of the system. And then, thresholds can be documented for future audit references. Again, change management, we all understand this, the criticality, and of course, in traditional system development life cycles, also auditors used to get involved in the change management cycle. What are the rollback plans? Auditors used to evaluate and give their opinions. Then this is something, ongoing monitoring the auditors can play in, and, they can help to identify drift by independently, being a watchdog, or, they have their own data analytics tools which can help them to, identify and work with the system, the business teams to share their observations. Last but not the least, when it comes to retiring the system, there has to be a proper documentation of the archival decisions, explainability, whether it is kept adequately, that why and for what purpose the system was built, and why it is being retired now, and what kind of the next system is being built, or whether prerequisites are built for the new system. So this is a probable answer to the challenges that an AI system is posing to the risk professionals, that how being part of the development cycle can help auditors as well as the programmers to come up with a better response to the challenges. Now, again, it makes a lot of sense, or rather it's very much important for auditors to know what are the regulatory and some important standards framework that we have to be aware of. To talk about, say, NIST risk management framework, it talks about the govern, map, measure, and manage framework. And clearly here, the focus that auditor has to put on is that is the organization following these 4 function cycles in every AI system development. Then in terms of ISO and IEC, there is a lot of focus on the governance, whether the AI systems are governed at the policy, procedures, and objectives, roles, and controls. The question is, can the org demonstrate a documented AI management system? Another framework is European Union AI Act, which talks about the risk classification and also certain conformity requirements. So the auditors are posed with a question as to are all the AI systems have got proper adequate risk classifications, and whether the documentations are in conformation with the law of the land there. Now in India, the RBI and SEBI are the key primary regulators who are immediately concerned with the AI systems, the algorithms. The law and some framework or guidelines are yet up. To just give an example where the SEBI has quoted, some senior person, some chairman has at one forum said that in the near future the AI is going to be the biggest challenge to the securities market. So this kind of statement coming from some senior authority is very, very interesting. Or rather, it shows the importance of what kind of thinking is going on with the regulators for this thing. But the point is, we have to, as an auditor, look at really, are we prepared for that kind of scenario when some regulations come in this regard by RBI or SEBI or any other regulator for that matter. And really, for that matter, Isaca professionals are certainly at an advantage, because we are ahead of in the curve for that matter than many other professionals. Then COBIT framework, we all understand, somewhere or the other, that do AI systems have a mapping of the COBIT control framework within the SDLC of the AI systems. So hitherto we have seen that, how the AI systems pose challenge, what could be probable solutions, and, what is the regulatory framework that is coming up. Now, all this where, we saw in the first part how the controls are challenged, what are the additional risks that are coming up in the control areas, what are the AI system challenges and the probable solutions to that. Now we look at how AI can add to the audit and control function. That AI is really helping a lot to the auditors and to the designers to, bring better controls into place. So let's look at this capabilities that have shifted for the auditor. The first and foremost is that now hitherto, auditors, as an auditor, we used to use some traditional data tools like, you Excel and some other typical EDI tools which we are using. But now with the advent of AI, there are very advanced tools available, like CIDA is one of the tools that I know of, where you can look at the data in entirety, whether it is millions of data sets or billions of data sets. You can really look at those data, and there are probabilities that you can cover 100% of the transactions, and again that too in real time. So as an auditor, we need to be very, very fast to adopt to these new tools that can help us and make our life better. The machine learning models are available in the system, in the market, and this can really help to identify the trends, some patterns, which can really go a long way to identify the anomalies in the systems of AI behavior, and also some fraud detections or early stage of the fraud indications. The next thing is the natural language processing. Some capable tools are there in the market, which when can help our life, can make our life very easy to, when we have to deal with a lot of documentation, go through it and analyze and see the risk factors involved therein. The last one is certain predictive risk scoring tools are available, like Power BI and Tableau and many other tools which are pure, though of course pure dashboard tools, but there are many visual techniques which can really highlight some of the data, which plainly if you look at the data sets or the indicators we may not be able to understand, but the visual forms, when we look at those data, you can clearly identify certain patterns. And with this help of this tools, we can look at data in real time. As the transactions happen, we can look at how the things are changing in practice, and what kind of risks that are emerging, and if there is any need for an alert for either auditor or for the management. These are some real world audit use cases, like in different functions. I have tried to do some search and bring it here. Now in the interest of time, let me touch upon not all of them, but maybe one or two. One thing, as an automation professional, I really like this, this process mining is an area where, as an auditor, or, some tools which can really bring a lot of difference. That any audit, when it is repeatedly, any process, then when it is repeatedly executed by any system, there are logging tools available, and these tools are capable enough to identify patterns within the processes, and really those process mining data, once available, they can identify a lot of exceptions in the process, the behavioral part of the processes, that certain steps which are not used or which have become redundant in the processes, so certain optimization opportunities. And also as an auditor, once the exceptions and the patterns are available from these tools, we can do a lot of opinion forming on those things. Well, I'll not go through each one of these in the interest of time, but there are really good use cases available. Now, From static rules to AI-driven controls, let's look at this example. We have talked a lot in abstract, but when we look at with an example, there is a scenario in which finance analyst credentials are compromised. Some fraudster has compromised the analyst credentials. What he has done is, somewhere at 2 a.m. in the midnight, he has accessed the payroll files and has been able to try to initiate some huge amount of money to transfer to some unknown accounts, and thereby try to bring a fraud into action. Now, when we look at the scenario of traditional controls, that is static controls, how the controls will behave. So we all know that these are the logic check, role check, action check, time and volume and other checks. Some of them are the controls that typically we put in place in the traditional system. Not that all these controls, but at least login check, role check, and action check. So when the credentials are compromised, the login check will pass through. Even the role check will pass through. Because there is a right credential used, the role-based matrix will allow the access to the files which are, otherwise not accessible to certain individuals. And as a result, there are no time checks or volume spike checks or geometric checks which are identified in the role-based systems. So the static rules will tick each one of them whenever they are placed. And once they all are ticked, then the transaction will just pass through. So there are likely chances that the fraudster would be able to succeed in his motive. However, the same scenario when we look at in a behavioral and kind of a control that is built, the AI kind of a control, probably credential check it will pass through. But time anomaly, the volume, the geometric anomaly, the location of the person who is accessing the system, and probably the transaction value, all these controls or the data points, the system will look at it in an entirety. It will not look in independent of each one of them and just put a tick mark for each one of them. It will look at the overall and give a combined risk score. And the risk score is high, so this particular transaction may not pass through. So the idea here is to give a perspective as to how the static traditional controls versus AI driven control when put in place can bring a difference. Now the last and the most important part of our today's discussion is how do we design an accountable and auditable AI system. So idea is to put the controls by design. So we'll look at some some principles of designing an AI system which results into an accountable AI system, some governance structure that we'll talk about, and some explainability standards that AI systems should stick to. So there are 7 principles which I have been able to identify and put together, which to my mind will make the system accountable. The first and foremost is the transparency. The AI decisions have to be transparent and human readable with the logic or the reasons why the decisions have come up. So the system has to stick to this principle while designing. There has to be an immutable audit log that, while the program is running, when the algorithm is running, what all the data point it has touched, how the weights of different data points it has put in, and finally how the decision has been arrived by the system. They all have to be logged. And again, this log has to be independent of the algorithm and the data set which the algorithm is using. There has to be an independent set of data which is not readable or editable by the algorithm. Then there has to be a human override architecture, which allows whenever a decision of an AI is impacting an individual, there has to be an option available to that individual to override that particular decision by the AI. There has to be a model versioning. Of course, we know, I mean, versioning controls while designing the systems. And then lineage is very important thing that, the data, because the dynamic nature of the data in the AI system, that it continuously builds on the new data. The logic gets refreshed, the algorithm weights get updated with every transaction data. The lineage, or the traceability of the data, the validation controls on the data are very, very important. There has to be certain gates before the system passes through and goes to live. The bias and the fairness gates have to be very, very strict and well documented to make sure that the systems are fair. I mean, the AI system is fair and it's not really biased. There has to be a continuous monitoring once the system goes into the production. Of course, it is true for any system for that matter. But here what is important is that the drift thresholds or the performance floors have to be defined, and there has to be some individual or human being at the helm who is responsible for the escalation if something is going wrong. Then finally the accountability, that at the end something goes wrong, and it cannot be that the team has done this or the system has done this, or it is the vendor who is responsible. No, there has to be a clear-cut governance structure defining the accountability within the organization. Now, these are the principles of designing an accountable AI, which can help to behave the AI, I mean responsible AIs for that matter, I would say, to come into existence. Now, there is some governance architecture as to who is owning the AI system. Now, these are some of the roles that I have tried to describe, and what kind of accountability that each role will have for AI systems. There has to be an AI owner. Now, again, in the interest of time, I'll briefly give an overview that these roles are not really very strict. It can really it just explains the different dimensions of the roles depending upon the size of the organization, the criticality of the AI system. This role can be combined with I mean, more than two roles can be combined with single individuals, and it can be optimized for that matter. But what characteristics of individual or the functional owner that each of these roles should have, let me just quickly ponder upon that. AI system owner has to be typically the business user owner. The person who is got business stake in the system has to be the AI system owner. The model risk manager is someone who is doing an independent validation of the models, and he sets the performance. So he can be kind of a the system analyst for that matter. Then compliance officer is somebody who is from some legal function who does mapping of the legal requirements and remains responsible for those things. Then data governance lead is somebody who is from the IT team, who understands the data and the metadata of the system. Then internal auditor, of course, someone from internal audit function, the senior enough person who understands the AI dynamics. And IT and security of the AI system has to be, rested with somebody from the IT infra team. Now, all this different role creates a governance structure around the AI system, and it also brings a lot of accountability for anything in the AI system if something goes wrong. Now, how do we make the AI systems auditable? Because at the end of the day, the systems will have to be audited by the auditor for getting kind of an assurance around it. And our parent body Isaca has come up with a very good checklist for auditing the AI systems, and the entire checklist talks about the explainability dimensions of the AI controls. Now, these are the 6 dimensions of the explanations that are needed by an auditor from an AI system. So what are those? The first is the rationale. any decision by the system has to be explainable. That what is the basis, what is the logic, what are the data that is used, and what is the decision tree that is used by the AI system has to be clearly auditable. The auditor will look at, how the system is transparent enough in terms of decisions that is proposing. So what is the rationale? Second is the responsibility, that who or what is responsible for a particular decision. The idea is to identify clear lines of responsibilities for the decisions made by the AI systems. Then again, those responsibilities may be within the system, that is some data point or some logic of the system which is responsible, or at the end of the day, some individual who is responsible for those decisions. The data in terms of tracking the origin, nature, the lineage is very important, because auditor will look at how clean the data, what are the validation and the integrity checks are applied, so that everything becomes explainable for that matter. The fairness, auditor would look at or expect for the explanation that how your system is behaving fairly, how it is treating different features, or for that matter, different dimensions of the decisions in a fair and transparent way. The next is the safety and performance. If the system is safe, what kind of safety measures are in place, and what are the performance measurement indicators are defined, and how they are tracked, what are the benchmark for that matter. And at the end, at overall level, different impact it is creating in terms of societal or ethical or environmental or regulatory impact. There has to be documentation around it before designing the system or during design of the system and so on. What all the impact has, whether they have been assessed, and whether it is continuously, like just a quick example about impact is whenever we ask a question to any GPT, the amount of power it consumes is, say, at least 10 times to the power that Google would otherwise consume for a simple query. So you can imagine, the different impact that it can create in terms of the environment. So at the end of the day, the auditors would expect all these audit enablers to be available from any AI system. So if a designer or a programmer is able to bring all these things, all these evidences in place while designing the system, it can really make the system auditable. So with that, I'm done with my, all technical things. Just a quick recap of, what we have talked is, in the first section, we just talked controls that must evolve with the time, with the changing behavior of the systems. Again, the AI has also become an enabler for the auditor, that we talked in the third part. The second part we talked about is, what are the challenges and what are probable solutions to talk, when we are auditing the systems, and, how do we create a design of the AI system that is, auditable and accountable. So with that, I'm done. I'm leaving here the forum open for questions, if any. And, on the slide, I have put some actionable items by different roles, which can be of interest to maybe some of you. So with that, I close my deliberations, and I would request the organizers, if any questions have come up, we can talk about them.
Yeah, so the forum is now open for all to have any questions. Let's put forward. Don't think we have any questions from any of the attendees. It looks like.
Yeah, please provide the email address here, as well as the audio is not clear at my end.
Okay, so we have a question from one of the attendees. What are the two AI tools available in the market to address all the risks identified?
Very smart question for that matter. I would say that, at least I have not come across any such tool which can identify all the risk. Now you can probably as a answer to this, I can say that if you have a system design documents, probably what you can do is you can use some kind of GPT, with due care about the confidentiality and privacy, and ask it to evaluate and come to your help as an auditor, to identify some risk and give some solutions around it. I mean, that's the only thing as of now I can. But there are individual tools to probably available, like as we talked during the session, that if you have to look at the bias factor of the risk, that there are certain tools available. So it's an evolving field. Actually, there are no clear-cut answers for this. So that's it about it.
Thank you. Really understand that. So with that, we would be coming to an end of it. It's my pleasure to honor. It's my honor to extend our heartfelt thanks to Mr. Pritesh Mashru for taking this time for and sharing his insight with us today. Your session was not just timely but also profoundly enlightening in a world where we are evolving some stages of artificial intelligence in the reshaping the way we think about controls, compliance, and governance. Your perspective helped us to understand and navigate these changes with both clarity and confidence. Thank you for that. And on behalf of everyone, uh, I would thank you for sharing your expertise, your time, and vision. We truly appreciate your effort to make today's session both informative and inspiring. We would look forward to have more sessions like this from for our chapter in future as well. Thank you once again.
Oh, thank you, everyone. Thank you, Vishal, Zalak. Thank you, everyone, and all the participants. Thank you very much.
Thank you so much.
Bye-bye.
Bye.